Hello everyone, my name is Hyunhwa or Henna. I'm with Scrum Nursing at UNLV. The poster that I'm presenting today is about functional levels and DNA methylation in blood related to MTBI, which was based on two separate pilot studies with very similar goals or aims here, which was we tried to identify long-term impact of MTBI on cognitive, psychosocial, and sensory motor performance. Also, we tried to investigate blood DNA methylation markers. So in study 1, we did global methylation ratio, which is not necessarily related to gene activities or biological mechanism. But study 2, we did whole genome DNA methylation sequencing, which we tried to link to cognitive declines after repetitive head trauma in a professional fighter sample, which was from professional fighter brain health study. The PI, Dr. Bernick, is my co-author in my study. Study 1, we recruited voluntary participants until the pandemic started last year. It's still ongoing study, but human subject recruitment is kind of paused at this point. But we were able to identify 21 with MTBI based on their self-reported, but we followed the MTBI diagnosis criteria by American Congress of Rehab Medicine. So 67%-ish is male, same amount whites. 27 years old on average, or so more than 70% has multiple or more than one injury. Actually, the average number of injury was 2.6. 14 control was included. Only age between these two groups was significantly different in terms of their demographic variable. So we control for age for the following analysis. Assessment, we use a different assessment tool. My team, Sungcha Lee, who's at Green Valley State University right now, developed mHealth app for walking balance, which we are using also for my other sports concussion protocol. And the blood sample was used for blood global methylation ratio, but also we are currently analyzing microRNA profiling analysis on NanoString platform. The result at this point, so we were able to identify a big difference in cognitive, especially in episodic memory, much lower in mild TBI, higher anxiety, also wider walking movement in mild TBI versus non-TBI here. And in terms of blood global methylation ratio, the orange here is MTBI, so they have a higher ratio, meaning they have, in general, on average, they have lower or down-regulated gene activities compared to healthy control. Sleep disturbance was higher in MTBI as well, but it became insignificant when we control for age. In study 2, we included 20 professional fighters' blood samples. Baseline blood sample was used for methylation sequencing, which was performed at NIPM sequencing lab. And we used cognitive performance processing speed score from CNS fighter sign baseline, and also T2, T3, T4 follow-ups. So we tried to identify difference in that processing speed score and then correlate with methylation profiles. Data analysis done by Dr. Yoon, my other collaborator. Based on the data quality, we decided to include 9 total fighters information or data for analysis. So in this small figure, I tried to make it visualize. So this left side, 4 people are 4 fighters with cognitive declines over years. So we name them decliner, and these 5 are non-decliner. And the 2-digit number here are their age at baseline, and ethnic groups, and also their sports type of sports are also included in the figure. And here, number of professional fights is in green, and years of professional fighting is orange. So in a way, I can see there's not much difference between these two groups in all those background variable. So with the principal component analysis, there's a heat map on only methylation profile, so no clinical information was included in this analysis. But those two already show very big difference between decliner and non-decliner group. And so with a differential analysis, we were able to identify 149 hypermethylated and 199 hypomethylated genes in decliners. So in those hypermethylated, so specifically deregulated genes in FGFR, the fibroblast growth factor, also PI3K, those are known to be very related to multiple inflammatory process after brain injury. Also, the growth factor receptor 10 as well, upregulated or hypomethylated in tennessine C or TNC, which known to be very important for recovery after TBI. Also, cadherin 11, interleukin 1 receptor antagonist, and also insulin-like growth factor 1, and so forth. Network analysis, we identified deregulated networks related to organismal injury, neurological disorder, which affects axonal dysfunction, and also altered the dopamine feedback in CAMP signaling. Also, one of top common upstream regulator was BDNF, and this finding is kind of in line with BDNF upregulated BDNF expression is related to injury-induced neuropathic pain in the sensory system. In summary, we observed persistent cognitive, psychosocial, and sensory motor function impairments even long after, so even 7.1 years after in the injury on average in my study 1, in hyper or altered or higher global methylation ratio in that study 1 sample. Also in study 2, we were able to identify hypermethylated axonal degeneration gene related to subsequent cognitive declines in 1 to 3 years later. So I think I went over the time limit, but so if you have any question about my study, feel free to reach out to me, and thank you for your attention.